this quick since we only have the room for an hour, I assume, again. Welcome to the Climate Science Center's first interdisciplinary seminar series of the semester. A couple announcements before we get started. The first Science by the Glass event for the semester that resumes on Tuesday the 14th. A better way to spend Valentine's Day. At Fox and Hound. I spent probably some Valentine's Day there too. 5 to 7 p.m. Melanie Tatum will present on trash to cash text recycling turns to scholarships. So have that on your calendar. Also, don't forget to tune in to globalweirdingseries.com every other Wednesday at 10 a.m. For a new episode of Global Weirding featuring Dr. Hayho. In this series, she tackles myths about climate change. You can also tune in to her live Facebook chat every other Thursday at 7 o'clock Central. So make plans for that. All right. Today's seminar is going to be on climate change and education, which, considering what happened about a half hour ago, seems particularly relevant. Our first presenter is Dr. Jacqueline Cañas-Carroll. She's an associate professor in the Department of Environmental Toxicology and an associate director of the STEM Corps. Dr. Cañas-Carroll's current research focuses on the area of nanotoxicology, with an emphasis on fate and toxicity of carbon nanotubes in both terrestrial and aquatic systems. She's published over 25 referred articles and 3 book chapters. She's also the 2008-2013 recipient of the President's Excellent in Diversity and Equity Award and the 2013 Chancellor's Council Distinguished Research Award. She's also recently named an integrated scholar by Texas Tech University. Ladies and gentlemen, Dr. Cañas-Carroll.
Yeah.
That, we get down there, but no. Okay. All right. Welcome. Thank you for inviting me to be a part of this panel. So I'm an associate professor in the Department of Environmental Toxicology, and my research is sort of related to climate change. However, I do teach a lecture on climate change and how that impacts how contaminants move in the environment. I teach only graduate students, and I guess I'm fortunate because I'm in a department where the students are environmental toxicologists. They're concerned about the environment, and so what I teach related to climate change, I don't get a lot of pushback. I don't know if people do, because where I'm at, everybody is really concerned about the environment, climate change, and so, okay, thank you. So as I mentioned, it's a graduate level class, and we look at how changes in both temperature and precipitation are going to affect how the contaminants move. It's an environmental chemistry class that we're teaching this in, and so it's just one lecture, but I include it because I believe that it's important, and our students are actually, as environmental toxicologists, are going to be faced with this issue for their entire career, probably. So I think it's important, and as far as I know, this is probably the only lecture in our department that actually addresses this, even though we do have faculty that are doing research related to this. So how changes in the precipitation and the temperature are going to affect how contaminants move in the environment, which will ultimately affect where we find them and then potentially what organisms can be exposed. And so the way that I presented in class is to talk about what climate change is, even though they should all know, and then show them some studies that are published in the literature, so how environmental toxicologists look at the idea of climate change and how that impacts contaminant movement and toxicity. And then what I do is walk them through this figure from the peer-reviewed literature, and I apologize, I forgot to put the actual citation for this paper, but I give them this figure, and this figure has a very detailed legend that corresponds to all the A, B, C's that you see up here. And so what we do is we walk through this and we talk about how either changing temperature, precipitation is going to affect the movement in the different compartments. So we have in the air, up in the top, the A through E, and then letter J talks about like in a soil system as do the G, H, and I. And then you can see here K through M on the bottom is talking about in a aquatic system. So we go through this, and then on the exam, I always ask them questions from this figure. I've been doing this lecture now probably 4 or 5 years, and I use this because it's a really good summation of what will happen if you get these changes in temperature and or precipitation, and how that might affect crop contaminants food. You're supposed to be brief, right?
Question.
Yeah.
Well, let's save questions till after all the presentations. Thank you. All right, next up is Dr. Heather Greenhall Spencer. She's an assistant professor in the Department of Curriculum and Instruction at Texas Tech. She's interested in the ways embodiment, materiality, and global. Good word for me. Global forces shape the ways we think about, use, and learn with digital technology. Dr. Greenhall Spencer is published in multiple international journals in education, and she teaches courses on e-learning, diversity ideologues, and policies, and educational philosophy. Ladies and gentlemen, Dr. Greenhall Spencer.
Okay, so yeah, that's Greenhall Spencer. So I teach a lot of classes on how to learn and how to teach with technology. And one of the things that I focus on in my research and also in my classes is e-waste. Can you hear me okay? Okay. One of the things that's important, I believe, and this is something we talk about as students, is that when we think about learning with digital technology, when we think about teaching with digital technology, we also have to think about what happens to that digital technology. And so we focus on how e-waste happens, the circle of e-waste, and what are things that as educators we can do. So one of the things we talk about are the ways that e-waste contributes to pollution. It contributes to pollution everywhere, but specifically in the Global South and developing nations. The Global South has a sort of unfair burden because so many of our e-waste, our cell phones, our computers, our old devices are actually dumped in countries in the Global South. You can see some of the contributors in the blue boxes, some of the known e-waste dumping sites in the white boxes. And again, just kind of more arrows about where our e-waste and where Europe's e-waste goes. So you can see the Global South sort of bears the brunt. One of the other interesting things is the way gender plays out in this. Often it is women and children who are more affected by e-waste. First of all, because culturally in many of these countries, it's actually the women and the children whose job it is to disassemble some of these devices to find the precious metals in order to sell. But another reason is that, again, culturally speaking, it is often the women and the children who go get water. So they go to wells, often contaminated wells. And so they are more exposed to the toxins that have been produced by e-waste dumping. Okay, that's different. Okay. Hopefully, okay, I don't know what happened there, but we're going to start here. One of the things that we think about as we think about the global crisis of e-waste is we think about, well, what can education do? What kind of interventions can education make? One of the things that's interesting is these are the signatories of the Kyoto Protocol. You'll notice that there are very few non-signatories. The green are the signatories. The red is, and the gray are the people who did not sign it. The yellow, those who are considering it but have not yet ratified it. So US is actually one of the only nations, and definitely the only developed nation, who refused to sign the Kyoto Protocol. And I think this is reflected in, this is research that I've been doing where I've taken databases and laws and policies and sort of amassed them into who is mandating environmental education in their primary and secondary education, who is mandating education for sustainable development in their primary and secondary education. The countries in red are the countries that I have thus far been able to figure out have mandates that you have to have some sort of form of teaching on the environment, on ecology, on sustainable development that includes both jobs production as well as how to help the environment, how to kind of understand and think about ecology as well. And you'll notice that again we have both developing nations and developed nations, but again the US is one of the only developed nations that has not mandated environmental education. Now part of that is because we don't have a state or like a government, a nation education system. Most of educational decisions and curricular decisions are actually left up to the state. There are a couple of states in the US, Washington State comes to mind, that do actually mandate some form of environmental education. But most of the time, most states do not mandate it. You're not required to teach about it. Even in, like, for example, the science TEKS that we have now, it's optional. It's not required to do that. One of the problems then, of course, with that is it creates a lot of citizens who don't know much about the climate. They don't know much about ecology. They don't know much about the environment and how what we are doing changes the environment. So again, one of the things I do in my courses is I talk about, well, okay, how are we as teachers and educators who use technology, how are we contributing to e-waste, to some of these global problems? And we take some surveys. How many times in the past 15 years have I used any of these devices? How many times have I disposed of these devices? And if you'll just take a moment to kind of think about the last time, you got your last cell phone, how long did it last? Where did you take it? What did you do with it? Are you sure that the place that you took it really does recycle them, or were you just hoping that they did? It's kind of we're thinking about what we can do and how we can become educated about how to make interventions into e-waste. And then one of the things that I do is I also encourage my students to think about in their own courses. Some of them, well, all of them are graduate students. Some of them are practicing teachers. Some of them teach undergraduates. And we say, first of all, well, how could you green your course? Are there ways that you could think about how you use technology even in your own classes and think about ways to make greener decisions? And the next thing we think about is how is it that we can start making changes even in the schools where we're at, even if they're not mandated. And some of the projects that some of the students have come up with is recycling collection areas. So the school will actually set up a bin that says, if you want to recycle some of your electronics, come here. We as the school will make sure it gets sent to someplace that is certified to be a recycler of electronics. Another thing is there are various entities that actually take your old cell phone or old other device and they repurpose it for other things. Like cell phones for soldiers actually repurposes your cell phone so that it can be used in satellite band so that soldiers can call home. And then one of my favorite ones is Hopeline. It allows women who are in domestic violence situations to be able to, without being seen, come pick up a phone, have it with them in case they feel like they would need help and need to get out of the situation. So lots of different ways to kind of rethink how we use our digital devices so that we're not contributing to the e-waste problem, and lots of ways to kind of use these opportunities as a way or as a talking point, as an entrance point for teachers to be able to talk to their students about e-waste and about the ways that digital devices can actually contribute to climate change and changes. And then that's my thing. You can ask questions.
All I know is Sprint gave me $20 off the last time I traded phones, and that's the last I
There you
saw
go.
of it. So hopefully they did what they were supposed to do with it. Next up is Dr. Jerry Dwyer. He's a professor in the College of Education. He's currently the director of the Center for Integration of STEM Education and Research on campus. His current interests include the mathematical education of teachers, the scholarship of outreach, computational mathematics, and complex dynamics. He has published over 30 referred articles, as well as numerous conference proceedings and posters. 2011, Dr. Dwyer was named an integrated scholar by Texas Tech University. Ladies and gentlemen, Dr. Jerry Dwyer.
afternoon. And thanks to those of you who invited me here because I didn't know I had anything to say about this stuff. I have a sort of an interesting, I suppose, connection on all of this because I spent a lot of my life focused on being an applied mathematics modeler, developing mathematical and computer models for various problems in mechanics. And then throughout the second half of my career, I switched over to very much taking an interest in the education of students in these matters and eventually to the education of teachers. And so it's kind of like a sort of 2-minute summary of where this went, and that is the area that I worked in applied mechanics was that of fracture mechanics, how things break. And I worked on various areas, why would a wing fall off a plane if there was a crack on it, or why, and some critical sort of stuff here and there. But the one area that I began to get very involved in was the breaking up of glaciers. So I started looking at glaciology and the fracture of glaciers. How does ice break? So, sorry, just thought of an SD pun there about breaking the ice. But essentially, it's called the calving of glaciers. In other words, a crevasse appears in a glacier, maybe 3,000 feet up on the side of a slope, and that slides down the side of a mountain. And eventually, when that place where the crevasse is reaches the sea, the big chunk of ice falls off. And of course, that makes an iceberg. And we all know what happened to Titanic. So, you know, that's important, and it was important in 1912. But of course, it's the melting of icebergs, as many of you scientists will know, is partly contributing to the rise in sea level. But of course, it's also interestingly contributing what happens to water when you put ice into it. It makes it colder. So it's actually making colder water, so which in some sense can create minor increases in temperature, and it affects, I mean, I come from the southwest of Ireland. It rains all the time. Why does it rain all the time? Because there's a warm wind from the Atlantic, the whole Atlantic cycle. There's some fancy word that someone else remind me of again about, what is it, that cycle of the water going around. The what? Yeah, there's some other word as well. Like Gulf Stream, that's right. Spending half my life influenced by the Gulf Stream, I should really remember. All I know is that it always came from the southwest. And so, but I mean, if you make enough cold water in a different place, it could actually alter that. So that's a kind of a strange unintended consequence. And as I said, I'm sure there are other people know more about that. But I spent a lot of time working on that type of thing. And then I began to get into sort of educational work. And I would visit schools and I would talk to kids about, I don't know, I do my research, or I'm a mathematician, I do numbers and I do statistics. But the only thing that seemed to get an awful lot of interest is when I started talking about the iceberg. People were actually interested in it. So as I began to talk to kids and to see what we would do in schools, I thought one thing, there are probably very few people educating teachers who happen to have a sort of a background in applied mechanics. And so it was a kind of a strange engineering background. So I sort of said, how can I bring some of this kind of background into the education world? And I ended up eventually working with developing little modules, activities to simulate glacier type of things. And we turned them into, we called them integrated math science lessons in the middle school. And we ended up editing a book on this type of stuff. But I have devoted a section in that to the actual study of ice and glaciers. And it's, I mean, some of the simple experiments, I mean, there's the classic physics and math experiment where you just put a piece of ice into water and just look at the level of the water and how much, and there's a wonderful proportion problem, how much ice is under the water and how much ice is over the water. And it's always quite surprising. Is it only something like 1/10 of the ice is all you can see? There's an awful big, which I suppose is what happened to Titanic again. There was a lot more ice than they expected. And so, but we have little experiments like that, and there's one, this was a kind of a fun one where we have kids, if you like, watch a glacier. So they kind of create a big chunk of ice and they have to put it in the fridge, and when we come back next week, they have to leave it out for a bit, and you try and put a crack in it and you try and watch it slide down a slope. But it attracted a lot of attention, and what I found is that there are the related activities then, because you have to understand different aspects of science in order to understand that. But I think actually modeling a little mini glacier in a sort of a lesson plan gets kids actively involved in doing something. And I have, as I said, moved away into the world of doing a lot of more direct mathematics, teacher education, and that type of thing. But every now and again, some story comes up that kind of reminds me of it. And many of you may have seen about 2 or 3 weeks ago that there's a huge chunk falling off the Antarctic, you know, and I suddenly realized that's the stuff I was modeling, because they actually showed a picture of this huge fracture. Now, I can say that my little piece of computer code could measure a 17-mile fracture, but there's some kind of a scale thing going on there, and you could refer back to it. And there's another story that got me as well, because I often, some scientist unfortunately passed away because he fell into a crevasse in somewhere, I think might be Greenland or somewhere. These are dangerous things. You know, I have friends who lived on glaciers, and they said the noise is amazing, you know, that you can hear it constantly moving, cracking, opening. And the problem then is if you get fresh snow and you have this big opening and you don't know there's an opening, and it can have catastrophic consequences. But this is obviously, as we know here, it's a live and important prospect. And my issue then is to try and bring that through mathematical models to middle school kids or to somebody like that. So the only other thing I would say sort of it, and I said, I haven't been doing a lot of this in education right now, is that I also feel like that I happen to be a runner and a semi-vegetarian and all those things. So some kind of, I don't know, coaching, mentoring, personal life that we want to exhibit the need to save the environment. I currently keep my house at 59 degrees, and there's a lot of people shivering and thinking this is intolerable. So just so I can take off my jacket in this building. Thank you.
Dr. Ward, don't sell yourself short. I think a lot of kids take your class just to hear a lecture in an Irish accent. I know that.
It's the Gulf Stream coming up.
Our final panelist is Dr. Patricia Solis. She's the co-director of the Center of Geospatial Technology, a research associate professor of geography, and is an adjunct associate professor for the Climate Science Center at Texas Tech. Her research involves geographic technologies, climate change, sustainable development, water resources, and geography as a discipline for higher education. Dr. Solis has developed more than 50 competitively funded projects totaling more than $9 million from federal sources such as the NSF, NASA, USAID, U.S. Department of State, and others. Ladies and gentlemen, Dr. Solis.
Well, let's see how this goes. I'm the one causing some of the problems here with trying to do some multimedia for you. I want to tell you about, actually, this is my program. I want to tell you about the Youth Mappers. This is actually a research project that is funded by the U.S. Agency for International Development. Texas Tech is the lead. We co-founded it with George Washington University and West Virginia University. It's a consortium now. After 1 year, those 3 universities, we've grown to 52 universities in 18 countries, where we support students to basically fill in the map, where information and data, spatial data, is needed to make decisions. And oftentimes those decisions are about effects of climate change. We're supported by USAID and their Mapping for Resilience program. So they are the ones who come to us and say, we need this information in this particular place, trying to make communities more resilient to the changes that we see happening. So my approach with this education piece of this is trying to help students understand the part about climate change is that it's not going to be felt the same way everywhere around the world, and not the same by the same people in those places. Different people in different places are going to experience climate change in different ways. And this is one way that, one of the contributions, I think, to this project. So this is here. This is a map of all the chapters that we have. There is an education component, thanks to Dr. Lee. He's here, so I can thank him in person. He came to me a little more than a year ago and said, would you like to teach an independent study class about your research project? And we have a handful of students that need to graduate and take a new class. So would you do that? And I said, that sounds like a great idea. Working with students all over the world would give me a more formal approach to the education component of this. And I walked into the class with Dr. Lee on the first day, and there were 29 students in that independent study class. So it's now, actually, we have it as a service learning course, special topics class, and I've done it 2 more times since that time. And just so if you want to see a little bit more about this, you're all welcome tomorrow night to come to my class. At 5:30, we're going to do what is a mapathon, or a mapping party, and everyone's invited. Free pizza thanks to the Teaching and Learning Professional Development Center. And with that, I want to just show you a little bit about what the students are doing, dealing with issues like flooding, risk mapping, hazards, refugee. We sometimes map in refugee areas, and you can kind of see a little bit more from this wonderful video, if it plays, by Inside Texas Tech. They did such a great job. I really wanted to share it with you.
You could just narrate.
I have plan B. I have plan B. Let's see if this works. If this works. They said they could do this.
You could just turn on closed caption.
Could be. I don't know if it has closed caption. Here's what I'm going to do. On my computer here. This one?
Other mic.
I think it's on. I think you can hear it. Let's try. Here. You want to hit this one? I hit this one. Let's see.
Are we all back to zero?
Creative technology. Ready? Let's just see if this works.
1, 2, 3.
Try to sync it up.
Disasters happen all the time, and with this skill, the citizens, scientists can just respond at any moment. What you're seeing here is called a mapathon, which is really basically a mapping party
You wanna
where
start
we
over?
get together and we try to create
Can you hear it?
geospatial data for a particular cause or purpose.
They'll be able to look at and come up with population data and be able to make decisions about screening for malaria mosquitoes.
Try to do
Youth
this.
Members is a network of student chapters around the world. Right now we have 39 universities in 12 countries. Tonight we had a group from Nigeria and from Colombia and our co-founding University of West Virginia University. Everyone's mapping in the same place, and we will be doing a little friendly competition to see how well we did and how many edits to the map that we made and how much we contributed.
I'm going to just sync it up here for you.
To get a lot of features mapped. So when there's this competition, everybody wants to map more, to create more features.
Everyone knows about Google Maps, so that gives you some idea about what online mapping is about, but this is a little bit different. OpenStreetMap is kind of like a wiki, so that people can actually add to the map. The technologies have been around for about 10 years, but just in the last few years has it really become something that is very easy to understand and accessible to everybody using the tools from the humanitarian OpenStreetMap team. Anyone can learn this technology. It's very easy. We make it possible and part of the mapathon to teach people how to do it. So you don't have to be an expert in mapping or geography. You just have to be willing to learn and spend a little bit of time.
OpenStreetMap is easy solver. So all you need to do is create an account and start and join a project that's already there and start editing. So once they created a username and password through on OpenStreetMap, they will complete it from their home, from their work, and also what they can do, they can also find other projects they're interested in. Okay. What we did for Mozambique project is once the student follow the link, it will direct them to the map, to the aerial image of Mozambique, and on that aerial image, the students will add streets and lines, and they will define that as a street line. They will also draw a polygon around each house. So those people on the ground who are doing the spraying for mosquitoes, they will know that this is a house, this is a street. If we want, this area was not covered, so we know we need to follow that particular street, and that will lead us to that area. We can spray it and go back. So it will save them a lot of time and a lot of effort.
Our maps that we made last spring for Mozambique helped them find about 15% more houses. So there was a lot of people missing from the map. They were going to be missing from the campaign. And it could possibly have made the campaign much less effective. Young people are not the leaders of tomorrow. They're actually leaders today. And that's what we're really trying to create, that space for them to take action and use their skills and learn at the same time. They have a lot to contribute, and they're very good examples for all of us.
So you get a little taste there. One of the things that we're going to be doing tomorrow night is mapping in the Philippines, and there, as you know, Philippines are right in the path of typhoons, and there's a lot of flooding that happens in that part of the world. And so the data that they're creating, they're going to add the buildings, add roads, so that there can be, first of all, disaster prevention planning for, some inevitable things that are only going to increase in intensity and frequency with climate change. And they'll actually be used by the Red Cross, by the humanitarian development community. And also, oftentimes, there was a hurricane in the Philippines not too long ago, a few years ago. So we mapped part of that area that was affected, and that data was also used for the recovery. And then later on, used by the damage assessment organization. So the students learn sort of a whole range of things about what happens to communities as a result.
Well, we've got about 7-8 minutes for questions. If you guys want to sit out here, if not, you're welcome to just sit there if you want to. You may have to turn around to answer questions behind you, but it's up to y'all. So we do have about 7 or 8 minutes for anybody that's got any questions. Yes, sir.
I have 2 questions. The first one is, where is your event tomorrow? Because before I came over here, I got an invitation, a reminder of a wind energy symposium that's taking place at 5:30 in this particular room tomorrow night.
Yeah, it's not here. We're in the GIS lab on the 2nd floor of Holden Hall, in the GIS lab.
But the original question I had earlier, and it would deal with the first 2 speakers. I was in Chile the last 2 months, and while I was there, several newspapers talked about a global waste pool, maybe you could call it a Bermuda waste pool, e-waste, in the South Atlantic, of e-waste just circling in a big circle. And so the article in Spanish, but that doesn't matter, talked about the almost impossible way of that e-waste deteriorating and so forth. And so, given the last talk, it occurred to me, I wonder if there are any other parts of the world where lake ocean currents are creating waste holes or waste pools, and then there would be a related phenomena of the fish or other mammals that go into those dead spaces in the sea and then question is, how many people know about this waste pool in the South Atlantic?
I did.
Go ahead.
Yeah, and in fact, while I don't know the numbers on the transformations of fish in the Atlantic, in addition to contaminating water in the water supplies of villages, even minor cities. This is not just a totally rural phenomenon, but you also get the contamination of fish. You also get the contamination of any sort of plant life. I mean, I think the graphic you showed, as soon as your water is contaminated, everything is contaminated, all of your food sources. And so that's one of the difficulties, is trying to figure out ways to teach the contributors of e-waste better ways to deal with it, so that those who are in a place and geography where they are more affected don't have to bear the undue burden of our habits.
Yes, sir.
No, I was going to change the question. Go ahead. Go ahead.
I was just going to remark how, as an education theme, that we've all, I think, focused on those connections, like getting your students to try to make those connections between what do you have to do with the things that you see in the other parts of the world. Like maybe in Lubbock, you don't know that you could be affecting the ocean. It's so far away. The icebergs, I mean, it's fascinating that there is this direct connection. I think that's what we're all trying to do, is make real to the students how connected they are.
Yes, sir.
Yeah. So I think, Patricia, you raised an interesting point. That was one of my questions to the group. I mean, having taught biology for 32 years, I mean, one of the problems that our educational system has gotten itself into from all levels is we teach a lot of fact, but we don't teach how to understand complexity and the relationship issues of information in a way, because we want everything in black and white. We want it clear cut, and biology and anything we do is not clear cut. There's continuums and gradients, and I think all of you brought up examples of how you might help to explain that. But the problem, it seems, is that at the educational level, we don't use it necessarily unless people are specifically interested in doing that. What we teach are facts, because that's what we test for.
Yes, true.
Yeah. Yeah. So I guess the question is, how do we change that? Because that's the argument about any aspect of climate change right now. That's why we have alternative facts.
Yes. And honestly, this is something that in education, this is something we care about very deeply, right? How do you change the education system such that students can learn and use more higher order thinking skills?
Right.
How can they learn about complexity? How can they learn in different ways for different students, more personalized paths, more openness about what counts as the scientific method even. There have been pushes for that, and some of those are actually reflected in some of the tests. Some of the tests now are much more open answer tests rather than just multiple choice tests. That costs money, like serious money, to not just produce but grade.
Right.
And so there's also a pushback, especially from government's perspective, who does not know.
What they will pay that. Right, yes.
But they don't want to put the money into it. And so there are at least from what I've seen within the space of K-12 education, there are problems all the way around that we have to do in order to make this a part of our culture, rather than something that the good science teacher does on the days when they're not teaching to the STAR test.
Right. Yep.
Yes, sir.
My question refers to, is there any effect of the solar cycle on the climate change, or person? None of these figures at that point, but I was wondering if someone had studied or thought about it, if there is any impact of the solar cycle on the climate change.
Anyone? Solar cycle?
The information that I know of is that you'll see the amount of change in terms of affecting the Earth in terms of solar input, because the amount of solar radiation that does impact the planet, it doesn't seem to have major, unless there is a major related phenomenon occurring on the Earth, like increased volcanism during a low solar input. Then you can have some synergy there. But beyond that, I don't know of any solar cycle that's related.
Also, aren't we, well, from what I think
Right,
Dr.
right,
Hayes says, we're
right.
actually, where we're at now, it should be decreasing
Right.
instead of increasing in temperature with the,
Solar inputs.
yeah, solar inputs.
Because we go either way. Increasing the temperature or raising the temperature.
Yeah, like I said, I think there are some slight influences of that, but right now we would be in a decreasing phase of that if what we were seeing. Right.
One more question, yes, sir.
Yeah, I'm curious about the e-waste. Do we know, I mean, obviously you do, what the different percentages of material that is? Like some of it's going to obviously be plastic, some of it's going to be rare metal. And are there innovations? I kind of lost faith in people who do anything that's not against their self-interest. But maybe we can design some of the stuff to disintegrate faster. The plastics or something like that. Is there any innovations in that area?
Okay, so yes, and I can't speak to innovations in plastics, but I can say some changes in how we make glass that goes into our devices, and even some of the rare metals and chemicals that are used in production that then get released back into the atmosphere when parts of the devices are burned in order to get some of the rare metals out. A lot of those are starting to change actually, and in fact, I read a paper actually fairly recently that talked about even in the last 15 years on our cell phones. Our cell phones are actually, I don't want to say healthier for the environment because they still produce a lot of waste. But yeah, there are people who are thinking about that. Are there ways that we can make it this so they're less toxic? Although most of that thought process goes into not how do we make it change to better affect the environment. There are chemicals that can literally affect the brains of children who touch them for just a couple of hours a day. And so we're starting to get rid of some of those chemicals just to kind of stop the literally touching bad, damaging things, from happening. I think that's where a lot of the research is going. How do we keep this from harming children and women who are touching these devices after they're trying to remove the metals, and less about how do we really think about the larger effect of creating these devices and then getting rid of them so easily. And I think you're right. I think that there's this sort of built-in obsolescence that goes into a lot of these devices.
Well,
and
it's necessary to account for the system.
Right, exactly. So that's difficult. I don't know that anyone's deeply doing research to solve that.
Maybe if it's implanted in some way, part of
It's embodied. Yeah.
Yeah, then people are less inclined to want to have surgeries.
And you just like update your list.
I do know that there are engineers that are working on things like smart disassembly. So trying to come up with new materials and ways to take a cell phone, like a whole bunch of them, and put them, and apply heat or pressure to get them to basically come apart into different pieces that can then be further destroyed or recycled or done something with. So I know that there's an area of engineering that's involved in that.
That's all the time we have for today. Let's give our panelists another round of applause. Be sure to check out and make sure to look for next month's seminar. Same bat time, same bat channel. We'll see you next time.
Please take the cookies on your way.